Albert Einstein, the man whose name has become synonymous with brilliance, was born on March 14, 1879, in the southern German city of Ulm, which was then part of the German Empire. Ulm, nestled in the Kingdom of Württemberg, was a significant urban center during the late 19th century. His father, Hermann Einstein, hailed from Buchau, Württemberg, and was an Ashkenazi Jew. Hermann's early education was in applied mathematics, a field in which he showed remarkable aptitude. However, the financial constraints of his family forced him to abandon his studies, and he later worked in a feather-bed business operated by his cousins in Ulm. His mother, Pauline Koch, came from a Jewish family well connected in trade and commerce within Württemberg. She married Hermann in 1876, and Albert was their first child, followed by a daughter, Maria, born in 1881. The family's economic challenges led them to move from Ulm to Munich in 1880. Hermann, with the support of his brother Jakob, attempted to start an electrical engineering business. Munich, a hub of innovation during the electrification era, seemed the ideal place for their business to thrive. Albert was enrolled in a Catholic elementary school and later transferred to Luitpold Gymnasium in Munich in 1887, a prestigious institution that would shape his early academic life. Yet, the Einstein family's fortunes took another turn for the worse when Hermann and Jakob failed to secure a contract to electrify Munich. Undeterred, they moved to Italy in 1894, first to Milan and then to Pavia. Albert remained in Munich initially, but the rigid and traditional education system at the gymnasium left him disillusioned. The inflexible rote learning system that stifled his curiosity drove him to persuade both his parents and school authorities to allow him to leave and join them in Italy. The move to Italy marked a significant phase in young Albert's academic journey. While his father had hoped he would follow his footsteps into engineering, Albert's talents were already clear in his burgeoning interest in physics and mathematics. At the age of 16, he had already taught himself advanced algebra and geometry, laying the foundation for his future, groundbreaking work in theoretical physics. Albert's intellectual growth was further fueled by a family tutor named Max Talmud, a man with expertise in optics and ophthalmology, who was hired to teach Albert advanced mathematical and scientific concepts. It quickly became apparent that Albert was outpacing his tutor in many subjects, including calculus, algebra, and geometry. But Albert's talents were not limited to the sciences. As a teenager, he also delved into the works of great philosophers, including the German Enlightenment thinker Immanuel Kant. At just 14 years old, Einstein was able to grasp and understand Kant's complex critique of pure reason, a feat that astonished his tutor and hinted at the depth of his intellect. In 1895, after a few years in Italy, Einstein took a significant step toward his future as a scientist. At the age of 16, he sat for the entrance exam at the prestigious Swiss Federal Polytechnic School in Zurich, a renowned institution for physics, mathematics, and engineering. He scored exceptionally well on the technical exams, but was ultimately not admitted due to his youth. However, Einstein's resolve remained unshaken. In the following year, he passed the Swiss Matura, a secondary school equivalency exam, and with it, gained the opportunity to enter the Polytechnic School in Zurich. In 1896, this marked the beginning of his formal education in physics. While studying in Zurich, Einstein's interests began to solidify. He became fascinated with the emerging fields of quantum mechanics and the nature of light. At the time, the scientific community largely adhered to the theory that light traveled only in waves. However, Einstein harbored doubts about this theory. He believed there was more to the behavior of light than met the eye, and this skepticism would soon drive him to challenge the established norms of physics in groundbreaking ways. During his time at the Polytechnic, Einstein also began to understand the importance of scientific research in the real world, though it was clear that his future would not lie in conventional career paths such as engineering. After completing his studies in Zurich in 1900, Einstein was still faced with a lack of academic opportunities. Despite his exceptional academic record, universities across Central Europe were slow to offer him a teaching position. This frustration led him to a temporary position at the Swiss Patent Office in Bern, where he worked as a patent examiner. While his job was largely administrative, it provided Einstein with the opportunity to focus on his own scientific research in his spare time. It was here, at the patent office, that he began to work on the theories that would later define his career. Einstein's work at the patent office, which involved evaluating various inventions and devices, may seem unrelated to theoretical physics at first glance. However, it has been suggested that his experience evaluating mechanical devices and their functionality played a pivotal role in his ability to conceptualize and approach problems in physics with a unique, innovative perspective. This, in turn, shaped his later discoveries and contributed to his rapid rise as one of the world's leading scientists. In 1905, often referred to as Einstein's Annus Mirabilis, or Miracle Year, the world of physics underwent a monumental transformation thanks to a series of 4 groundbreaking papers that Einstein published in Annalen der Physik, a leading scientific journal. These papers would forever alter the trajectory of modern physics and cement Einstein's place in history. The first of these papers, titled On a Heuristic Viewpoint Concerning the Production and Transformation of Light, introduced the concept of the photoelectric effect, for which Einstein would later receive the Nobel Prize in Physics in 1921. At the time, the scientific community adhered to the wave theory of light, which described light as a continuous, undulating wave, much like ripples in water. However, Einstein's work challenged this theory. He proposed that light also exhibited properties of particles, which he termed quanta, or photons. This radical idea explained the photoelectric effect, where light striking certain materials could eject electrons from their surface. The theory demonstrated that light could be understood as both a wave and a particle, a concept that would later form the foundation of quantum mechanics. Einstein's second paper, On the Motion of Small Particles Suspended in a Stationary Liquid, as required by the molecular kinetic theory of heat, addressed the phenomenon of Brownian motion, the random movement of particles suspended in a fluid. By explaining this movement mathematically, Einstein provided solid evidence for the existence of atoms and molecules, which had long been theoretical concepts. His calculations confirmed the molecular nature of matter and gave empirical support to the atomic theory, revolutionizing our understanding of the physical world. The third paper, On the Electrodynamics of Moving Bodies, introduced Einstein's theory of special relativity. Building on the work of James Clerk Maxwell and Hendrik Lorentz, Einstein proposed that the laws of physics remain the same for all observers moving at constant speeds relative to each other, and that the speed of light is constant, regardless of the observer's motion. This theory demolished the long-standing notion that space and time were separate, fixed entities. Instead, Einstein unified them into a single entity known as space-time. This insight led to the now famous equation ES-mc2, which shows the equivalence of mass and energy, a discovery that would later have profound implications for nuclear energy and the development of atomic weapons. Einstein's fourth and final paper of 1905, Does the Inertia of a Body Depend Upon Its Energy Content?, introduced the concept of mass-energy equivalence. Through his famous equation E/mc2, Einstein demonstrated that a body at rest possesses intrinsic energy, which is proportional to its mass. This insight would eventually form the theoretical foundation for nuclear energy, leading to the development of both peaceful and destructive uses of atomic power. The equation fundamentally reshaped our understanding of the relationship between mass and energy, and underpinned many of the technological advancements that would follow in the 20th century. These four papers, though initially published in relative obscurity, began to attract increasing attention as their far-reaching implications became clear. Einstein's work challenged centuries of established scientific principles and laid the groundwork for the future of physics. His theories would eventually lead to the development of quantum mechanics, special and general relativity, and cosmology, revolutionizing humanity's understanding of the universe. In the years following his Annus Mirabilis, Einstein's career soared to unprecedented heights. Despite the groundbreaking nature of his 1905 papers, Einstein's rise within the scientific community was not instantaneous. For several years after his publication of these works, he continued working at the Swiss Patent Office in Bern, while simultaneously conducting research that would later define the course of modern physics. It wasn't until 1908, when he was appointed to a position at the University of Bern, that his academic career began to flourish. This marked a turning point, allowing him to devote himself fully to scientific research. The subsequent years saw Einstein's growing influence in the academic world. He was appointed to the University of Zurich's newly created chair of theoretical physics in 1909, and by 1911, he had moved to the prestigious German University in Prague. Einstein's work continued to evolve rapidly, moving from the realm of special relativity to the exploration of gravity and the structure of the universe. It was during this period that he began developing his theory of general relativity, which would soon become one of his most important and revolutionary contributions to science. General relativity, first proposed in 1915, redefined the understanding of gravity, where Newton had conceived of gravity as a force acting between two objects. Einstein's theory described gravity as the warping of space and time by mass. Massive objects, like planets and stars, create indentations in the fabric of space-time, and these distortions cause the effects we observe as gravity. This radical departure from classical mechanics had far-reaching implications for the understanding of the universe, from the behavior of planetary systems to the dynamics of black holes and the expansion of the cosmos. As Einstein's fame grew, so did the recognition of his contributions. His theories had profound implications not only for physics, but also for the emerging field of cosmology. In 1915, Einstein was appointed to the Prussian Academy of Sciences in Berlin, a position that allowed him to focus entirely on research. It was here that his general theory of relativity was developed in full, and it was here that Einstein began to expand his thinking about the nature of the universe. His research on relativity provided the theoretical foundation for the study of phenomena such as black holes, the bending of light around massive objects, and the dynamics of the expanding universe. Einstein's theory of general relativity was put to the test in 1919 when British astronomer Sir Arthur Eddington led an expedition to observe a solar eclipse. During the eclipse, Eddington and his team measured the bending of light from distant stars as it passed near the sun, providing experimental confirmation of Einstein's prediction. This was a momentous achievement, not only for Einstein, but for the entire scientific community, as it confirmed the validity of general relativity and established Einstein as one of the greatest minds in history. Despite the acclaim that accompanied his groundbreaking work, Einstein remained modest, never seeking fame or personal glory. His commitment to scientific inquiry and intellectual curiosity was paramount. He continued to refine his theories and expand his research, always driven by the pursuit of knowledge rather than the accolades that came with it. Throughout his life, Einstein maintained a sense of humility and a strong belief in the importance of questions over answers. By the early 1920s, Einstein's contributions to the world of physics had not only cemented his status as a leading intellectual figure, but they had also begun to shape the broader cultural and political landscape. His fame reached new heights as his theories of relativity gained recognition not only within the scientific community, but also among the general public. As Einstein's visibility grew, he became a global symbol of intellectual prowess and scientific advancement, often invited to speak at conferences and engage in public discussions. However, his rising profile came with its challenges. While he gained respect and admiration in scientific circles, his outspoken views on politics, peace, and social justice led to increasing scrutiny, particularly from nationalist and militarist factions in Germany. Einstein, a committed pacifist and social activist, was vocal in his opposition to war, militarism, and the growing influence of authoritarian ideologies, particularly in his native Germany. His stance on these issues would eventually have profound consequences on both his career and personal life. In 1933, when Adolf Hitler came to power and the Nazis consolidated their control over Germany, Einstein's position as one of the most famous Jewish intellectuals in the world made him a target. The rise of Nazism prompted Einstein to renounce his German citizenship and leave the country. As a vocal critic of the Nazi regime, he faced increasing hostility and even threats from the government. His Jewish heritage made him a particular target, and the Nazis were quick to denounce him, vilifying him as a Jewish intellectual and a threat to the regime's ideology. After leaving Germany, Einstein sought refuge in the United States, where he would spend the rest of his life. He accepted a position at the Institute for Advanced Study in Princeton, New Jersey, which would become the institution with which he would be most closely associated for the remainder of his career. In America, Einstein continued his work in theoretical physics, but his focus gradually expanded to include social, political, and humanitarian causes. He used his prominence to advocate for civil rights, nuclear disarmament, and the protection of intellectual freedom. Einstein's decision to leave Germany came at a time of increasing political polarization across Europe. As the 1930s unfolded, the tensions between countries grew, culminating in the outbreak of World War II in 1939. Although Einstein was a lifelong pacifist, the rise of Nazi Germany and the threat it posed to global peace and democracy led him to take a more active role in political matters. One of the most notable events of this period was Einstein's signing of a letter alongside physicist Leo Szilard, warning U.S. President Franklin D. Roosevelt about the potential for Nazi Germany to develop nuclear weapons. This letter, known as the Einstein-Szilard letter, played a significant role in the initiation of the U.S. Manhattan Project, which eventually led to the development of the atomic bomb. Einstein's advocacy for peace, however, did not prevent him from becoming embroiled in the ethical dilemmas surrounding nuclear weapons. Although he had signed the letter that contributed to the U.S. nuclear weapons program, Einstein later expressed regret about his role in the creation of the bomb, particularly after the devastating bombings of Hiroshima and Nagasaki in 1945. His pacifism and his desire for peace remained central to his worldview, and he became a vocal critic of the use of atomic weapons in warfare. Despite these challenges, Einstein's intellectual contributions continued to shape the future of physics throughout his time in the United States. He continued to explore new ideas and refine his theories, particularly in the fields of quantum mechanics and general relativity. His work during this period would lay the groundwork for later advancements in cosmology, such as the study of black holes and the understanding of the structure of the universe. In the years following World War II, Einstein continued to grapple with the implications of his scientific discoveries and their use in global conflict. Despite the disillusionment he felt about the role of science in warfare, Einstein remained deeply engaged in intellectual pursuits, particularly in his attempts to unify the fundamental forces of nature. By the late 1940s, his work focused on developing a unified field theory, an ambitious attempt to reconcile the forces of gravity and electromagnetism within a single theoretical framework. Though his attempts would ultimately be unsuccessful, this quest for a unified theory was one of his final major contributions to physics, and it kept him at the forefront of scientific thought even into his later years. Einstein's years in the United States were not just defined by his scientific work, but also by his public life. As a public figure, Einstein became an iconic symbol of intellectual authority and moral integrity. He was admired not only for his revolutionary contributions to physics, but also for his outspoken views on a wide range of social and political issues. His commitment to peace, his criticism of capitalism, and his support for Zionism in the context of the creation of the State of Israel made him a polarizing figure in many circles. Nevertheless, his reputation as a champion of human rights and intellectual freedom remained intact. In addition to his political activism, Einstein's personal life became increasingly complicated. His marriage to his second wife, Elsa, was characterized by emotional strain, and despite their outwardly close relationship, their marriage began to deteriorate in the years following Einstein's move to the United States. Einstein's relationship with his children was also fraught with difficulty. His sons, Hans Albert and Eduard, faced challenges of their own, and Albert's separation from his children after his divorce in 1919 remained a source of personal pain. Edward, in particular, struggled with mental health issues and was later institutionalized, leaving Einstein with a sense of profound sadness and regret over his strained family relationships. Despite the personal and professional challenges he faced, Einstein continued to influence the direction of scientific research in the post-war era. His ideas about quantum mechanics, particularly his skepticism of some of its more philosophical implications, continued to provoke debate within the scientific community. Einstein's disagreements with Niels Bohr over the nature of quantum mechanics, particularly their famous debates during the 1920s, became legendary within the field of physics. Bohr, a leading proponent of quantum theory, and Einstein, who believed that the theory could not be the final explanation of the universe, engaged in a series of public debates that have become a cornerstone of the history of modern physics. Meanwhile, the scientific landscape of the 20th century was shifting. The discovery of quantum mechanics, the exploration of atomic energy, and the continuing development of relativity were transforming the way we understood the universe. Einstein's theories continued to play a pivotal role in these developments, even as he struggled to integrate his own work with the emerging field of quantum mechanics. His role in the scientific community remained strong, but the increasing complexity of modern physics, combined with his own intellectual limitations in later life, made it clear that Einstein's groundbreaking work was nearing its end. As the 1950s unfolded, Einstein's legacy as a scientist continued to solidify, but his later years were marked by increasing physical frailty and a growing sense of the limitations of his earlier work. He had become, in many ways, a living legend. Yet, despite his fame and acclaim, Einstein's sense of self was still rooted in his commitment to curiosity and intellectual exploration. He continued to work on scientific papers, though at a slower pace, and began to focus more on philosophical and political issues. In particular, Einstein's reflections on the role of science in society became more pronounced as he recognized the profound impact his discoveries had on the course of human history. In 1950, he published his unified field theory, a final attempt to reconcile the fundamental forces of nature into one overarching framework. Despite its failure to be widely accepted within the scientific community, Einstein's pursuit of this theory remained one of the central intellectual pursuits of his later life. Even in his 70s, Einstein's mind remained restless as he sought to bridge the gap between general relativity and quantum theory, a challenge that would ultimately remain unsolved in his lifetime. His work in the field of quantum mechanics, which had already placed him in opposition to some of the field's leading figures, continued to evolve as new discoveries reshaped the landscape of physics. In his later years, Einstein's political activism also grew more intense. He had long been a vocal advocate for peace, but in the post-war period, the rise of nuclear weapons, the Cold War tensions between the United States and the Soviet Union, and the growing militarization of global politics intensified his sense of urgency. Einstein became a staunch critic of nuclear proliferation and the arms race, warning about the dangers of atomic weapons in the hands of competing superpowers. His vocal support for global disarmament and the establishment of international peace frameworks was intertwined with his advocacy for a new world order that emphasized the need for cooperation over conflict. One of Einstein's most significant political actions came in 1952 when he was offered the presidency of Israel following the death of Chaim Weizmann. While deeply honored by the offer, Einstein declined, citing his advanced age and lack of experience in political matters. However, his support for the Zionist movement and his belief in the establishment of a Jewish homeland in Israel remained unwavering. Einstein's contributions to the founding of the Hebrew University of Jerusalem in the 1920s had already established him as an intellectual leader in the Zionist movement. His relationship with the State of Israel was complex, however, as he remained a critic of certain policies, advocating for peace between Jews and Arabs in the region. In addition to his political work, Einstein continued to be a prolific writer and correspondent throughout the 1940s and 1950s. His private correspondence, which spans thousands of pages, provides insight into his thoughts on science, politics, and philosophy. His letters reveal a man deeply concerned with the direction of humanity and the role of intellectuals in shaping the future. Despite his personal struggles, Einstein's legacy as a thinker who transcended the confines of academia to address the most pressing social issues of his time was firmly established. By the mid-1950s, Einstein's health began to deteriorate, and his once vibrant intellectual activity slowed. The man who had once altered the course of human understanding of space, time, and energy now faced his own mortality. In early 1955, Einstein was diagnosed with an abdominal aortic aneurysm, a condition that, although surgically treated in 1948, resurfaced with devastating consequences. On April 17, 1955, Einstein was admitted to the hospital, but he refused surgery, choosing instead to meet his fate with the dignity and philosophical acceptance he had so often advocated. The following day, on April 18, 1955, Albert Einstein passed away at the age of 76. Einstein's death marked the end of an era in the history of science, but his influence continued to resonate across the world. His contributions to theoretical physics, mathematics, and cosmology had transformed the way humanity understood the universe, and his intellectual legacy would endure long after his passing. Despite the overwhelming grief of his death, Einstein's ideas continued to shape scientific research and popular culture, and his name became a symbol of brilliance, curiosity, and the relentless pursuit of truth. After his death, Einstein's brain was removed during his autopsy by Dr. Thomas Stoltz Harvey, a pathologist at Princeton Hospital. This controversial decision was made without the permission of Einstein's family, and the brain was later preserved for study. Over the years, the remains of Einstein's brain have been the subject of much scientific scrutiny, with researchers studying its unusual anatomical features in an attempt to explain the source of his extraordinary intellectual abilities. Some researchers have suggested that the increased number of glial cells in Einstein's brain might have played a role in his remarkable cognitive abilities, though the findings remain speculative. In the years following Einstein's death, his scientific contributions continued to inspire generations of physicists, mathematicians, and thinkers. His theories of special and general relativity revolutionized the way we understood the fabric of the universe, while his work on quantum mechanics and the photoelectric effect opened new frontiers in the study of atomic and subatomic particles. Einstein's equation, E=mc2, became an iconic symbol of the power of science to unravel the mysteries of the natural world. Einstein's fame, however, was not limited to his scientific achievements. He had become a global, cultural icon, admired not only for his groundbreaking work, but also for his humility, his commitment to peace, and his advocacy for social justice. In the years following his death, his image was used in countless books, films, and documentaries, and his legacy continued to be celebrated across the world. Albert Einstein's influence, both scientific and cultural, continues to reverberate even decades after his death. In the realm of science, his discoveries have not only reshaped our understanding of the universe, but also paved the way for a multitude of technological advancements. The applications of his theories extend far beyond the confines of theoretical physics. For instance, his work on the photoelectric effect laid the foundation for the development of modern electronics, from photovoltaic cells used in solar panels to the technology behind digital cameras and televisions. Einstein's theory of special relativity, with its revolutionary insights into the nature of space and time, has had direct applications in modern technologies like GPS, which relies on the precise measurement of time and the effects of relativity on satellite clocks. The very fabric of the universe, as revealed by Einstein, continues to inform how we navigate not just the cosmos, but also our everyday existence. His mass energy equivalence, encapsulated in the famous equation E equals mc2, has become an indelible part of popular culture, signifying the profound connection between matter and energy. The implications of his work, especially in nuclear energy, have left an indelible mark on history, leading to both the peaceful use of atomic energy and the devastating consequences of nuclear warfare. Beyond science, Einstein's personal philosophy and political views contributed to the shaping of modern thought. He was a staunch advocate for civil rights, decrying racism and inequality in all forms. His outspoken support for the civil rights movement in the United States during the 1940s and 1950s demonstrated his commitment to social justice, and he became a vocal critic of the oppression faced by African Americans. He also expressed deep concerns about the growing militarization of the world, condemning the use of nuclear weapons and advocating for global disarmament, particularly in the wake of the bombings of Hiroshima and Nagasaki. His commitment to pacifism, however, was complicated by the geopolitical realities of the time, including his brief support for the creation of the atomic bomb to prevent Nazi Germany from obtaining it first. Einstein's views on Zionism, too, played a pivotal role in the formation of the modern state of Israel. While he remained critical of some of the policies of the Israeli government, particularly in regard to its treatment of Palestinians, he continued to support the establishment of a Jewish homeland in Palestine throughout his life. His advocacy for Zionism was not motivated by religious fervor, but by a belief in the right of Jews to self-determination, particularly after the horrors of the Holocaust. As a public intellectual, Einstein was also deeply engaged in philosophical questions. He was fascinated by the mysteries of the universe and often pondered the relationship between science, religion, and the nature of reality. Although he identified as an agnostic, Einstein famously rejected the idea of a personal God and was critical of organized religion. His philosophical views were grounded in a belief in the power of reason and the need for scientific inquiry to continue expanding our understanding of the world. He once remarked, "The most incomprehensible thing about the world is that it is comprehensible, reflecting his awe at the universe's inherent order and his belief in humanity's capacity to understand it through science. Einstein's legacy is not just one of scientific achievement, but also of profound human insight. He was a thinker who transcended the boundaries of his discipline, whose work in physics was interwoven with his concerns about humanity, peace, and the future of civilization. Today, Einstein's name is more than just a symbol of genius. It represents the ideal of intellectual curiosity, the unyielding quest for truth, and the belief that the mind has the power to change the world. The enduring legacy of Albert Einstein is a testament not only to his groundbreaking scientific discoveries, but also to the far-reaching cultural and societal influence he exerted throughout his lifetime and beyond. His contributions to our understanding of space, time, and energy have become fundamental pillars of modern physics, but it is his character, his commitment to truth, and his moral compass that continue to inspire generations. As the world continues to grapple with the ethical, social, and environmental challenges of the 21st century, Einstein's philosophy offers valuable lessons. Einstein's deep-seated belief in the power of human curiosity and reason led him to engage with a wide array of intellectual, political, and humanitarian issues. In his later years, he became a staunch advocate for the rights of intellectuals and the need for academic freedom. He supported global efforts for peace, social justice, and the protection of civil liberties. His personal experiences with oppression, both as a Jew in Nazi Germany and as a political dissenter, gave him a unique perspective on the importance of intellectual autonomy and the need to resist authoritarian regimes. The personal challenges Einstein faced, his struggles with his family, his relationships, and his internal conflicts over his role in the development of nuclear weapons, highlight his humanity, his vulnerability, and his lifelong pursuit of ethical consistency. Despite his personal failings and occasional contradictions, Einstein's unwavering commitment to making the world a better place through the application of knowledge, reason, and compassion has left a profound impact on the course of history. Today, Einstein's legacy celebrated not only in scientific circles, but also in the broader world of culture, politics, and philosophy. His image continues to evoke the idea of intellectual freedom, of thinking beyond the boundaries of conventional wisdom to explore new frontiers. Schools, research institutes, and even cities are named in his honor, and his image is ubiquitous in popular media. More than just a historical figure, Einstein has become an enduring symbol of the power of the human mind to challenge, question, and reshape our understanding of the world. His personal life, filled with contradictions and complexities, serves as a reminder that even the greatest minds are not immune to the struggles of life. Yet, it is his resilience in the face of adversity, his ability to persist in the pursuit of knowledge despite setbacks, and his willingness to confront difficult ethical dilemmas that make him a figure worth remembering. His life is a model of intellectual courage and moral integrity, and his ideas continue to shape our world in ways he could never have fully anticipated. As we look to the future, Albert Einstein's legacy remains as relevant as ever. His contributions to science, philosophy, and human rights continue to inspire those who seek to push the boundaries of human knowledge and contribute to the greater good. The mysteries of the universe that he sought to unravel remain a source of fascination, and the ethical dilemmas he grappled with remain just as pressing today. Einstein's life reminds us that the pursuit of knowledge, coupled with a commitment to justice and humanity, is a path worth following